This is your quadratic formula review. Sometimes when you cannot factor a quadratic equation, you still have to have a method to solve it. That method is quadratic formula, which you've done before. This is just a quick review. We are not going to go over this in class per se, but you are responsible for it because there may be a time where you can't factor, and quadratic formula is your method for solving that quadratic equation. So let's go ahead and remember what quadratic formula is, and that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My method of solving quadratic formula is to go ahead and solve only this area, which is called the discriminant, first. It's much easier, takes a lot of the headache out of the problem, a lot of the confusion out of the problem. So we are going to go ahead and solve 2x squared plus 3x minus 20 equals 0. So the first thing I need to do is I need to write down my a, b, and c values. And of course, those are the values. This is our a, b, and c. They're just numbers. They're just coefficients. So we have 2, 3, and negative 20. So because we are only going to figure out the b squared minus 4ac, which is called the discriminant, I'm going to take my b value and square it. So 3 squared is 9, minus 4, and I'm going to multiply a and c together, which gives 2 times negative 20 is negative 40. Okay? So let's scoot this up a little bit. So now I have 9, and then 4 times, negative times a negative is a positive. 4 times 40 is 160. So 169 is my discriminant. That is the amount that's going underneath the radical. So the way I solve quadratic formula, you really don't ever have to write the whole formula down. You need to know it, but you don't need to keep writing it over and over. So now the square root of 169 is 13. That is what ends up being plus or minus 13, because that is the square root of our discriminant. So then we just need to add on the opposite of our b value, which would be negative 3, over double of our a value, which would be 4. 2 times 2 is 4. Once you have that, now we don't have any radicals left in our answer down here. This simplified to a whole number. So now we need to move that whole thing up. We always have 2 answers in a quadratic equation, so now I need to split this out and solve it twice. So I have negative 3 plus 13 over 4 and negative 3 minus 13 over 4. So let's go ahead and solve those. So negative 3 plus 13 is 10 over 4, which reduces to 5 over 2, 5 halves. And negative 3 minus 13 is negative 16 over 4, which reduces to negative 4. So those are your 2 solutions. Okay? Well, what happens if we don't have something that comes down to a whole number like that, and we have radicals left over? So let's try one of those. So let's move all of this out of the way. And let's go ahead and factor 5x squared. Sorry, not factor. Solve 5x squared plus 9x minus 1 equals 0. Remember that in quadratic equations, everything has to be set equal to 0. So if your equation isn't set up that way, you've got to get it there first. Okay, follow the same steps. My a, b, and c values are 5, 9, and negative 1. So my b value squared would be 9 squared, which is 81, minus 4 times my AC value, which is 5 times negative 1, which is negative 5. So my discriminant is 81 plus 20, which would be 101. This is the amount that goes underneath the radical in the quadratic formula. 101 is not factorable. There's no perfect square I can take out of 101. So it's actually as simple as it can get. So it's going to go there. The opposite of my b value is negative 9. And double of my a value is 10. So for this problem, that's my solution, and that's exactly where you stop. If you're going to graph that, you're going to change this square root of 101 to an actual decimal number to be able to graph. Okay, so that's your quick review. Under 5 minutes. There you go.